In this question, it is given that for a geometric progression, the first term is a. So the first term is a, and the common ratio is cos theta. So this is cos theta, and the domain lies between 0 and 1 upon 2 pi, which is half pi. It is also given that the second term is 8. The second term is 8, and the fifth term is 1 upon 8. So we have been given quite a few values that we need to keep in mind. We need to find the value of theta correct to three significant figures. So since this is a geometric progression, we will be dealing with ratios rather than the common difference. So we know that the formula for the common ratio is the next term divided by previous term. In this case, we can take the second term upon the first term because we are given both of the values. So common ratio equals to second term upon the first term. We know that the common ratio is 8, first term is a, and the second term is 8. We can substitute these values, so we have cos theta equals to a upon 8. Solving for a, we'll have a equals to 8 upon cos theta. Now we can solve for the fifth term. For geometric progression, the specific term number can be given by this formula, where it's first term into the common ratio to the power of n minus 1. Since we are solving for the fifth term, so we'll have the fifth term equals to a into r to the power of 5 minus 1. So the fifth term we know is 1 upon 8. We just found the first term, which is 8 upon cos theta. We can substitute that over here. So this will become 8 upon cos theta. And we know that the common ratio is cos theta. So this will become cos theta to the power of 4. Cos theta and this cancels out to become cubed. This 8 can go over here, so this will become cos theta cubed equals to 1 upon 64. The cubed value can go to the other side to become the cube root, so this will become cos theta equals to under root 1 upon 64. Simplifying this, we'll have cos theta equals to 1 upon 4 because 4 plus 16, 64 is 64. And the alpha value we'll get is it's 1.318. Let's make a grid. Now we know that the domain lies between 0 and half pi. So 0 comes here and half pi comes over here. So our answer lies in the first quadrant. So let's assume this to be our line, and this will be our alpha value. So the first answer that we have, the rotation is also our final answer. So the final answer for theta will be equals to within the given domain is 1.32. rounding to three significant figures as asked in the question. For the second part of the question, we need to find the sum to infinity. So we know that the sum to infinity, the formula is a upon 1 minus r. So sum to infinity equals to, we know that a is this and r is cos theta. R is cos theta. So we can substitute these values. We'll have 8 upon cos theta divided by 1 minus cos theta. Now, since we also calculated the value of theta, we can substitute it over here. So we'll have sum to infinity equals to 8 upon cos 1.32 divided by 1 minus cos 1.32. So our final answer will be our final answer is 128 upon 3.